In today's lesson, we will be talking about compounds and molecules and how atoms of different elements come together to form new substances. A molecule is a group of atoms that are bonded together chemically. These atoms are held together by what is called chemical bonds, which are simply strong attractions between the atoms, holding them together. A molecule can be made up of two or more atoms of the same element. Like in this example here, O2 is made up of two oxygen atoms bonded together. A molecule can also be made of two or more atoms of different elements. An example being water, which is made up of oxygen and two hydrogen atoms. Another example is methane, which is made up of both carbon and hydrogen atoms. When we have a molecule that is made up of two or more different elements, we call that a compound. A compound is a pure substance that is made of two or more different elements bonded together chemically. A compound is made up of two or more elements in a specific ratio. That means that there are always a specific number of each atom in that compound. For example, H2O, which we know is water, is always made up of two hydrogens and one oxygen atom, or a 2-to-1 ratio. If it doesn't have that 2-to-1 ratio of hydrogen to oxygen, it's not water. Another example is hydrogen peroxide. So it looks almost very similar to water. To be hydrogen peroxide, there are two hydrogens and two oxygens, or a 2-to-2 ratio, making it hydrogen peroxide. If it does not have this specific 2-to-2 ratio, it's not hydrogen peroxide. Based on this makeup or this ratio of its atoms, every single compound has a unique set of characteristics that we call properties. This means that every single compound has a set of characteristics that is different from all other compounds in the universe. The individual units of a compound are called molecules. For example, here I have one single molecule of water, and here I have one single unit or molecule of hydrogen peroxide. Some compounds are very small and simple, whereas others are very large, complex molecules. Let's look at some examples. So some of these very small, simple molecules are molecules that are only made up of a few atoms. Some examples: carbon dioxide, only made of 3 atoms, 1 carbon and 2 oxygens. Another example is methane, 1 carbon and 4 hydrogens. Pretty small, not too complicated. Water is another example, only 3 atoms, 1 oxygen and 2 hydrogens. There are other compounds that are made of molecules that are much larger and more complex. Sometimes these are made of large chains of repeating units, up to thousands of units long. These are called polymers. Polymer means many. What a polymer is a large molecule made up of lots of repeating units. Some examples of large complex molecules called polymers are plastics. As you can see here, this plastic polymer is made up of a very long chain of repeating units, a large and complex molecule. Another example is nylon. You may have seen this in your clothes before. You can see here a very long chain molecule, much larger and more complex. Another example is glucose, which is the sugar that's in our food. You can see here again, a much larger, more complex repeating molecule. When we talk about molecules, when we use them in chemistry, we also represent them using their molecular formula. Molecular formula is simply a way to represent a chemical compound. A molecular formula tells us several things about the compound that it represents. The first thing is the elements that are present in the compound. For example, here you can see that this compound has hydrogen and oxygen, and I can tell that simply by looking at its molecular formula. The second thing that the molecular formula tells us is the number of atoms of each element that are present in the compound. Finally, the molecular formula also tells us the number of molecules of the compound that are present. To read a molecular formula, there are 3 things that you need to know inside the formula. So we'll use this example here for CH3Cl as an example. The molecular formula first tells us the atomic symbol of the elements that are present. This lets us know which elements are present in the molecule. In this example, I can see that I have a C, that tells me there's a carbon. I have an H, that tells me there's hydrogen, and a Cl, that tells me that there's chlorine present in this molecule. The second piece of information that the molecular formula tells us is called the subscript. The subscript is the small letter that comes after the element. This tells us how many atoms of that element are present in the molecule. In this example, my hydrogen has a subscript of 3, the small number that comes after the hydrogen. That tells me that there are 3 hydrogens present in this molecule. Another trick that you should know is that none means 1. If there's no subscript actually written in the formula, we assume that that means 1. So for my carbon, I would assume that there is 1 carbon present, and for my chlorine, I would assume there's also 1. The last bit of information that we can find in the molecular formula is called the coefficient. This is the big number that comes in front of the entire formula. This tells us the number of molecules that are present. So in this example, I have 4 as my coefficient, telling me that I actually have 4 molecules of CH3Cl.